Hello, everyone. Welcome back. We've been talking about the internet, and today we're kind of transitioning from the internet into cybersecurity with encryption. So, encryption is the process of encoding messages to keep them secret, so only that authorized parties can read it. We take plain text that is something that anyone can read and transform it into text that is just unreadable unless it is decrypted. These days, the vast majority of the data on the internet is encrypted. Packets are sent across the internet. They're encrypted as they leave the source, and then, as we're going to see, they get decrypted on the back end. So, the contents of the packet, the bit that we call the payload. So, think back, we learned about packets. Anything that you send over the internet, any bit of data, it gets broken down into these smaller bits known as packets. Now, packets have two main parts. They have a head or header. Webcam doesn't look frozen. I'm moving over here. That may be you. Okay. So there's two main parts of a packet. We have the head or header, and there's important information in there like the destination IP address. Let's see if I can pull up a packet. IP version 4 packet. There is an image. It's coming from Wikipedia that I've used in the past. Yikes. Doing it on the fly. Y'all hear my cat clacking? Oh, here she comes. We may have a guest on today's program. All right, so when we first learned about packets, I showed you this image where it's all the information in a packet header. The most important parts are the source address, that is where the packet is coming from, the destination address, that is where the packet is going to, and these are IP addresses. The 32 bits indicates this is IP version 4. And we also have another super important thing, an identification number. Right? The packet gets broken into smaller and smaller sections, and then we send those out. Each section, each packet is tagged with an ID number. That way, once it reaches the destination, A, the destination knows that it has all the packets, and then B, it can put it back in order based on that ID number. So that stuff is in the header. The content of the packet, that's the payload. That is what is encrypted here, right? The thing is, we can't encrypt the header of the packet. Why? Tell me in chat. Why can't we encrypt the header of a packet? Right? Keep in mind the packet, the packet header, it contains this information. Why can't I encrypt this? Good. You need to know the IP addresses, right? These packets, they're going through routers. They're going through devices that help the packets go where they need to. They're effectively checkpoints. So along the way, it's going to hit a router. The router says, oh, you're going here? Well, this is the fastest route, so you need to go this way. Okay, so then it goes that way. And so those routers need to be able to see these IP addresses. This ID number, right? We can't encrypt the header. If you encrypt the header, then the routers won't know where it's in the packets. What gets encrypted is the payload. That is the contents of the packet, to prevent what we call packet sniffing. Packet sniffing occurs whenever the contents of a packet is analyzed by a third party. Encryption doesn't stop packet sniffing. It merely transforms plain text so it is unreadable by a third party. Let me kind of show you. I have a picture of Pickle Wit here. It's the funniest wit I ever saw. Right? If I open this just in a normal image viewer, it looks something like that. But if I were to open it up and say Notepad, I see this. This is kind of what we're talking about with encryption. What encryption does is it doesn't stop you from getting a hold of the packet, right? Packets pass through routers all of the time. What encryption does, it says, I don't care if you get a hold of the packet, you can't read it anyway because it looks like just hot garbage. That's the idea. So what encryption does, it doesn't stop you from getting a hold of the packet. It merely transforms the plain text so it is unreadable. Okay? This is where HTTPS comes in. This was developed as a secure alternative to the traditional HTTP. HTTPS is the communication protocol, is encrypted by TLS, or formerly its predecessor, SSL. So TLS, SSL, you don't have to worry too much about those, but they are essentially the protocols on how we encrypt these things. And they go through HTTPS websites. As of 2017, the average volume of encrypted internet traffic finally surpassed the average volume of unencrypted traffic. So this is fairly recently. The vast majority, what this is saying is that in 2017, that was the tipping point. Over half of the internet traffic finally is encrypted. Now, as we're going to see, encrypting, it's like compression, in that there's like some upkeep to it, right? You have to encrypt on the source side and then decrypt on the destination. And that just adds process, like extra process, to the whole transferring of data. And so that's the only real downfall. That is why it took us so long to go from unencrypted data to encrypted data. And realities are, like, if you have a website and you just don't really care, then there's no good reason. But you're going to see that now with all of the traffic kind of headed this direction, we'll hit a point where like 90% of traffic is likely to be encrypted. And how do you know? Well, if you go to a website, take my chat for instance. This is a little inception here. We have HTTPS up here in our address bar. Okay. And also the lock. This is a feature that a lot of browsers include now. Not only do we see the HTTPS, we see the lock as a visual indicator telling us that this is secure. Now, what that really means is packets going from me to Twitch, or you to Twitch, anybody that's using Twitch, the packets are encoded and decoded. Okay, so they are encrypted. Okay, we're going to talk a little bit more about encryption. I just immediately saw the question, what stops third parties from decrypting the data? We've got good encryption techniques, and effectively, and we'll talk a little bit more about these things, but effectively you can't. So you get a hold of a packet, it's encrypted, you can't read it. The only person that can, in theory, decrypt your data, decrypt the packet, is who it was intended for. And we'll talk about how that is achieved kind of briefly. So packets sent across the internet are encrypted before leaving the source, and then they are decrypted once they are received on the other end. Another place that we use encryption quite frequently is in a database. A database, is simply put, is like a table. I want you to think of like a Microsoft Excel spreadsheet. So whenever you go to a website and you create some type of login, including a username and password, those get stored in a Microsoft Excel spreadsheet. That's effectively what a database is. This is another place where you want to encrypt that. Okay? I'm going to ask the question. I want chat to respond here. But why would you want, if I'm a server, if I'm Twitch or Amazon and people are making logins with me and they create a username and password, and whenever I store those inside of the database, inside of the spreadsheet, why is the password encrypted instead of it being plain text just sitting there in the spreadsheet? Why would I, Amazon, Twitch, whoever, whatever website I am, why would I want to encrypt your password before storing it inside of a spreadsheet? stop the employees from getting a hold of it. That is definitely one way. What else? Privacy, privacy from what, right? In theory, only the employees. In theory, only the employees. There it is. Hackers. There's two sides of it, right? Not only do I want to keep Facebook, Twitch, Amazon, whoever, those employees from being able to see what my password is, more on that later and why that's important, but also hackers. What if someone were to hack into that website and get a hold of that database, that Excel spreadsheet that just contains everybody's username and password? That's a problem. Okay? So this is referring to authentication. This is the process of verifying that you are really the person who has the right to access a particular computer or service. When you create an account that requires a username and password, that account information is stored together in a database. The database that stores usernames and passwords can be very vulnerable to hackers, especially if that information isn't encrypted. Okay, so we're going to dive into this a little bit, but I'm glad that came up, right? If we take one table and it's every user's username and password in one spot, if the hackers get a hold of that one spreadsheet, that one table, they have everyone's username and password. That's kind of a problem. So to prevent this, passwords are encrypted with a one-way function. We call it a hashing function, right? Known as a cryptographic hash function. Okay, I'm going to kind of briefly explain one-way functions, and if you're interested in this, I encourage you to kind of look out there and see how this is actually achieved, but I'm basically going to dumb it down, to be honest. A one-way function is an algorithm that is easy to apply and hard to undo. Passwords are hashed before they are stored in the database, and when a user attempts to log in, the password they enter is put through the exact same hash function. If the passwords match, then authentication is successful. So what am I talking about with hashing? The way it gets kind of achieved in practice is using modulus, which is effectively division. Okay, and I'll give you an example. If we take three numbers, right? We had this question with compression in our first semester. If I give you three numbers and tell you to get an average of those three numbers, well, that's easy. You're able to do it. But if I give you the averaged number, and I told you if this came from three numbers, it's almost impossible to go back to what the original were. Right? I'm going to say that again. If I give you three numbers and I tell you to find the average, well, that's easy. Everyone knows how to do that. If I give you that exact same average and told you that I used three numbers, it's almost impossible to get back to the original three numbers. That's effectively how a one-way function works. It is very easy to apply. It's super easy to just take three numbers and average them. But to take the average number and get back to the exact same three numbers, that's nearly impossible. And when we say impossible, one thing you got to keep in mind is like relative to time, right? Some of you are probably thinking is like, well, I could get there eventually. Yeah, and computers can kind of get there eventually. Yeah, but think about how websites are preventing you from just trying to enter your password over and over and over again, right? If I get a hold of someone's user information, like their username, I could just go and try to enter any combination of passwords, and eventually I'll get there, right? Well, the ways that websites kind of prevent that is you're limited on the number of times that you can do that. Something like 3 to 10, and then they lock you out for a day or more or something like that. So this is the idea of a one-way function. It is easy to apply and hard to undo. Okay? So the way that we kind of make this work with passwords is that if we take every character, right, every letter of the alphabet, let's say, and we assign it a number, right? A is 1, B is 2, C is 3. You can get this kind of math function involving division or modulus to create this one-way function. So we assign numbers to all of your characters. We do some math on it, most importantly division or modulus, and then we use that to encrypt your password. Now what gets stored in the database is an encrypted password. It's going through this one-way function. When you go to log in, we take whatever you enter into the password section, we put it through the exact same formula where we convert the letters, we do a little bit of division, and if that matches what's stored in the database. That's how we authenticate you. That's how we know that the passwords match. Because what's stored in the database, it's not the plain text. It's not your raw password. One of the main reasons, again, that we do that is that we don't want hackers to get hold of it. Now, what's interesting here is that hackers getting a hold of your password for one website, it's kind of not a big deal, because if they're able to hack into the website and get access to the database that has all the passwords, well, they could just hack the website and kind of do whatever they want there anyway. So they don't really need your login. But I kind of want an answer here in chat. With that in mind, right? If someone is capable of hacking into a website and getting a hold of all the passwords, well, they're probably capable of just hacking the website, period, and doing whatever they want. So what's the point? Why encrypt the password then? What if the password has numbers? So we don't exactly have to assign, right, A to 1 and B to 2. You could skip down, right? 0 through 9 are basically already taken. And so you really start A at like 10, for instance. Something like that. So ultimately, the real reason that we encrypt passwords in a database is not for fear of someone hacking that website and getting hold of your password. It's actually kind of a social thing, is that people use the same password on like all these different websites. That's the real fear. It's actually not, oh, that website's vulnerable, they can go in, they have access to that account. Well, if they were able to do that, they could just hack the website anyway. The fear at that point is if they hack in and your password is being stored in plain text, then they could then cross-reference it on multiple websites and possibly just gain access through that. So it's kind of a social problem. And it's one of the reasons that I'm supposed to encourage you. I don't do this because I'm stupid. But you should be using different passwords for different websites for that reason. Now, in theory, every website is using good tactics. They're encrypting passwords before they store them into a database. But the fact of the matter is that some aren't. Okay? If you ever go to a website and you do a password reset, you say, I forgot my password, and that website emails you your exact password, you should run, because that website is not encrypting your password. What you see, and I know all of you have experienced this, if you go to a website and you say, I forgot my password, what they do is they tell you to do a password reset, because they don't know what your password is. Your password is encrypted garbage and stored in their database. But if a website just flat out emails you the password in plain text, that means they're not storing it encrypted. And that website is vulnerable. If that website were to get hacked and you use that same password for other websites, that hacker could then take your password, go try a multitude of places, and then all of a sudden your Amazon account gets compromised, or heaven forbid your League of Legends account gets compromised. So how does a website check if the passwords match if they don't know the password? Again, that's with this one-way function, right? We're going to take your password that you create whenever you register the account. We're going to put it through a formula and get some encrypted nonsense on the back end. Now, whenever you go to log in from that point on, what we do is that we take your login attempt password, put it through the exact same formula. And if the jumbled mess that we get out of that matches the jumbled mess that is in the database, we know that you entered matching passwords. Okay, even with password encryption, you want a password that is hard to crack via brute force. I invite you to go to howsecureismypassword.net. This is an HTTPS website here, right? I'll play along. Maybe I just throw it into a search. How secure is my password? Let's hope that the .net. Yeah, here we go. How secure is my password? So I'm going to type in my 100% legitimate password. I wish I had hair. That's not awful. It would take about 2 years. Now, this is referring to the brute force tactic that I was referring to earlier. If we were to take a computer and it just tried every possible combination of characters, it would take about 2 years to get there. This is what we mean whenever we're talking about, it being hard. I see we're over here memeing, but people do type in password. Right? That's not great either. Okay. So what happens is if we're only dealing with letters, lowercase a, b, c, d, e, f, g, that's only 26 letters. If we add in capitals, as we've kind of come to know, those are separate characters technically, well, we effectively double it. You throw in numbers and random symbols, and what you're doing is you're just adding time. You're making it harder and harder and harder to crack a password. Yes, so whenever we talk about this, it's not impossible, right? It's not impossible to kind of brute force your way through the password and hopefully get there. But it's a matter of time, and it takes a lot of attempts, right? Because if I just want to see, is this the password? I actually have to enter it into the login site, and most sites, the way that they kind of maintain this is they limit the number of attempts that you have. They'll lock you out after like 3 to 10 attempts or something like that. So I kind of invite you to try your own password here. This is why they suggest that you add things like random characters and numbers to your password to make it more difficult. If you really want to know the truth, what you should be using is some type of password manager. A lot of the browsers have them these days, like Firefox and Chrome. Whenever you go to create an account, they're going to be like, do you want me to suggest a password? And it's going to remember it within the browser itself. And what's great about that is they end up with something that's just a jumbled mess anyway that makes it really hard to crack. But it's like stored in the browser. And so that's what you're supposed to use. I still don't do it. Sorry, but I'm supposed to tell you that's what you're supposed to be doing because it is supposed to be what you're doing. Now, I'm going to end this with an XKCD comic on password strength. Okay, these comics, if you don't know, they are largely, a lot of them are programming based, but they take some pretty crazy concepts here. So here they're talking about in this first panel, this is a suggested password. We got uppercase and we got numbers in there, and there's ampersand, this is random symbol, and they're talking about how this makes it really hard to crack because we have such a wide variety of characters. And entropy theory is talking about like how long it would take in order to guess this if we tried to brute force it. And then you as a user, you're like, wait, did I use O or 0? Right? This is really hard for the computer to crack, but really hard for you to remember. Then down here, this is what they suggest, which I'm going to tie this all back in. Correct horse battery staple. This is harder for a computer to crack than this one. And then for you, as a user, this is much easier to remember. That's kind of, that's just something to kind of memeing about here. Right? We encourage this. Like websites now force you. You have to use random characters like exclamation points and underscores and ampersands, but it ends up creating really hard to remember passwords. If we were just allowed to do this, maybe password length is the only requirement that's necessary, then we would come up with passwords that are hard to crack. Now, one of the things I like about this is if we take this correct horse battery staple, correct horse battery staple, how secure is my password? We'll get cracked instantly, right? If you were making some type of program that is trying to crack passwords, what you're going to do first is not try every possible combination. What you're going to do first is go down the list. What is the most used passwords, right? But number one up there has got to be just literally the word password. This one is on a list because of this XKCD comic. Horse, I don't even remember what it is. That's a pickle wit. That's kind of also a pickle wit. Correct horse battery staple is on that list because the existence of this comic. I believe they actually tell us. They at least used to tell us why. Anyway, so with that in mind, I have seen some. I noticed this on Twitch. Whenever Twitch makes clips now, instead of using random characters to distinguish them, they're actually using just random combinations of words to make unique URL links for new Twitch clips. But we're actually going to pause it right there, I believe. Yeah, it's been about 30 minutes. So that's the stuff behind password. I encourage you, if you're super interested in the one-way functions, hashing as it's called, look into that. Login systems are actually kind of interesting if you plan to do something like web development. But we'll pause it there. We'll pick it up tomorrow. Let's chill.